Welcome to the video on graphing inequalities. If you have not done so already, please go over the Explore question with your group, discuss the questions and answer them below. Only take a couple minutes to do this. If you need to pause, go ahead and do that right now. Hopefully you have already gone over these questions with your group. If you have not, please pause and go over them before you continue. Here are some possible answers that you should have as we are exploring through this question. When the temperature drops below 68 degrees Fahrenheit in a building, the heater turns on. At what temperatures will the heater turn on? Write an inequality to represent the situation and graph the solution on a number line. First, let's model it. So let's talk about what this means in words. How would I represent this temperature in words? Well, in words you would say when the temperature is below 68 degrees. That's how you would say it. In symbols, since I want to use T for my temperature, I would write T is less than 68. T representing any temperature that is going to turn on the heater. When I ask you to graph it, I want you to look at my graph and notice I circled 68 on the graph. I have it as what we call an open circle, meaning you can see inside of the circle. Do not fill it in. You actually have to circle it and leave it open. I also shaded to the left all of the degrees that would turn on the heater. If for some reason it dropped to 40 degrees, the heater would kick on. The line is drawn to the left, and then the arrow at the end represents all the temperatures that it can be that are below 68 degrees. Check it. I want you to check a couple solutions. 63 degrees Fahrenheit. Is that below 68 degrees? Yes, it is. So that is why it is a solution. What about 74 degrees? No, 74 degrees is not below 68 degrees, so that would not turn on the heater. Okay. In the check it section, or connected section, we have a few things here I want you to check. First, what words helped you know which inequality symbol to use? Well, the words drops below. That will let you know that it was less than 68 degrees. Now in number 2 and number 3, you can see that I accidentally had 15 there, and I changed those to 68. It should be 68, not 15. So looking at the graph, explain why there's an open circle at 68. 68 is not included and does not turn the heater on. It has to be below 68, but that does not include 68 degrees. Why the shaded arrow and goes to the left? Because those are the temperatures that are less than 68. That is why they go to the left, and that's why the arrow goes to the left. Okay? What happens if I said the heater turns on at 68 degrees or below? Well, then I would have to add this little equal to bar underneath my inequality, because T then would be less than or equal to 68 degrees. That is what would kick on the heater. Now what does that mean in my graph? Well, I have a full circle there, and this time I filled in my circle. Notice the difference of the two circles. This one is filled in, which we call a closed circle when you fill it in. My line still goes to the left. And that brings us to question 5. When do I use an open versus a closed circle? An open circle is used when the number is not included. For example, it drops below 68 degrees, so not including 68, but anything below 68. A closed circle includes the number, such as when it is at or below 68 degrees. That's when it would turn on. So we fill it in to include that 68 would turn on the heater. So an open circle does not turn the heater on at 68. A closed circle does. If you need to go back and rewatch anything, go ahead. Otherwise, continue on with your question.